Let's start. Some words about me. I'm graduated in business informatics in 1986. That's a bunch of years ago. And I'm on the road as a business intelligence consultant since around about 1995. My main focus is and was and will be the Microsoft BI stack. It started for me with SQL Server 6.5, then SQL Server 2000 with OLAP services, analysis services, integration services, reporting services, all that stuff, which may be more or less familiar to you. That's it. In case of any questions, don't hesitate to ask. Also on the way of the presentation, and I will find out whether it's a good idea to answer the question right now, or maybe we have to postpone it for a little bit later. And the second point, if you have some questions regarding the understanding of my presentation, please ask right now, because I'm not so what's the right word? There's not so much routine on my side to hold such presentations in English. So maybe it's not so quite clear English from time to time. If there are problems to understand what I mean, then give me a sign or just jump in. Okay, let's go. There are 4 points of the agenda I want to talk about. The first one is the calendar date dimension, which is, oh, by the way, we are dealing we are in the area of business intelligence and data warehousing. I guess that all of you are more or less working in that area of informatics. Can you raise your hand shortly if you are not working in business intelligence and data warehousing? Do we have aliens here? 3, 2, 1, 0. Nobody raises hand. Okay, so we are in our inner circle. Okay, the next point is regarding some special things about dealing with fact data. And then we come to special circumstances, special questions, special jobs to be done regarding holiday management, holiday arithmetics. And then we are in our last point regarding date arithmetics. So here we go. In an information warehouse and in data warehouse, we need time references for all the data which are necessary, which we want to present, which we want to calculate, because there are only a very rare amount of data, close to 0%, for which it isn't necessary to have a date dimension connected to the data. We can say every data we have to deal with are data which have and which are related to a dedicated point in time. In much cases, not in only one point in time, also maybe in 2, 3, 4, 5 points in time. When the event happens, when it was recorded, when it was written to the database, when it was transferred to the data warehouse, when it was calculated, and so on and so on. Usually we have more than one date which is connected to the data we are dealing with in our data warehouse. So first of all, a date dimension can be a simple list of dates. In that case, there's not such a big need for a date dimension, but a simple list of dates are usually not enough. We need more information. Some of the tools, as well as SQL Server itself, offers the possibility to auto-generate date dimensions. They're also a feature in Power BI, I guess. All such auto-generated stuff is in the most cases not such a good idea, because usually we need more attributes as the generated dimensions hold usually. That can be, we have here a short sample with a date ID here and a date internal as a timestamp stuff. A date name in English, in Spain, ID for half year, name for half year in different languages, and so on. So usually we need more attributes, more columns as we get offered from auto-generated stuff. Okay. Depending on your business needs, there it is maybe necessary to have special dates for special circumstances, special dates which are related to special events or special points in time regarding your business, or regarding the public holidays. To be clear, are my employees are available or not, or things like that. That is a next point which can be interesting to you. And because of that, such information doesn't change over the time, usually it's quite easy to pre-calculate such things, such special dates, such special circumstances, and give them some additional attributes in our time dimension. Special circumstances in a date dimension also can be to have special records, special rows in our date dimension for special circumstances. You know that from all other dimensions, there are you able to have a kind of unknown element, or an all element, or an data not available element, or things like that. That is not so easy if you deal with a data dimension, because usually the key of a date dimension is a date or a date ID. That means that is not an attribute which can hold other values except date values. So one of the ideas to deal with this is, as you can see here, that you pick special dates. Sorry for that. Special dates that are the very first date which is available in the date range of SQL Server. To pick up that dates for special circumstances, for out of range, for invalid data, for null value delivered. That can be there can be a business need to deal with such stuff if you get data from outside, where usually a date is connected to, but sometimes not, for whatever reason, because of the delivering OLTP system. OLTP system has some not so clear rules, or it's possible to make free entries in that field, and you can enter not only a date but also other information, and so on. Some all the circumstances you need regarding data quality also relies on data quality for date information. Okay, simple marks for holidays. As I already mentioned, another point which is quite important for reporting stuff is to create hierarchies. One usual hierarchy is the year, half year, quarter, month, day hierarchy. Another not so usual one is the year, trimester, month, date hierarchy. That is, in that case, the year is split up in 3 parts, but for every part has 4 months. Another one is year, week, day. That's quite funny stuff. Maybe you know that regarding that a week can have a part on 1 year and another part on the following year. There's such quite funny things if you have to deal with that kind of stuff. I know that dealing with weeks is you find quite often in the German business areas. I don't know how often dealing with weeks is used in other countries in the European Union, in UK, in the United States. I don't know how important dealing with weeks is in other areas of the world. Okay, here's also a short sample year, half year, quarter, months, some days as a sample and some values here, only to illustrate the topic of hierarchy. Another thing you have to talk about, you have to thought about regarding a date dimension is unique date values, as we can see here. This is the 1st of January, 1st of February, 1st of March, and so on. And that's the 1st of March of, 2016. We also have a 1st of March of 2017. So one job to use date dimensions is to have that quite dedicated column which contains date, month, and year. But if you only have such stuff, you are not able to create a kind of cross table. And here comes the split up of day and year in the game. To be able to have such kind of report, which we have the months in the rows as well as the years in the column. It's not possible to have such kind of presentation if you have only the year, if you have only the year dedicated date column. So that is another thing you have to think about regarding the date dimension if you want to deal with some kind of cross table split up to present your data in reports. It depends a little bit with which reporting tool you are on the way, because of some of the reporting tools have a bunch of date and time related stuff inside and offer some possibilities from the tools like Tableau, like ClickSense, like Power BI. But the point is, if you rely on one of those tools, then you may be lost if you have to change the report front end. And as you know, to take care on separation of concerns, it is quite important to think about where do I place my real business logic. That's what we are not talking about right here, but dealing how you want to deal with calendar and date stuff is close to business logic, and it's a good idea to think about to place that kind of logic independent from the reporting tools you want to use. It depends on the circumstances that may be different from case to case, but in general, it's a point you have to keep in mind to deal with all that date and time stuff better independent from the front end tools and then layer before, in a business layer before you go to your data go to the front end tools. Okay, last point on that case is if you have to, whenever you have to deal with time information like hours, minutes, or something like that, please use a separate time dimension. Don't blow up the date dimension with hours, with minutes, with seconds. It's not a good idea at all. Questions so far? 3, 2, 1, 0. Okay, let's go ahead. Dealing with fact data. To have a date dimension is not the reason to have a data dimension is not to have a data dimension. The reason is to use the data dimension to connect the data dimension to the real business data. Right now, there are two approaches of connecting the calendar dimension to fact data. One approach is to use a kind of surrogate key ID. That's what we can see here. Just a second. Here we go. This is an integer column which has from right to left the day, the month, and the year. That is integers is stored in 4 bytes, and usually to make joins, filters, where clauses, and so on, using an integer field is in the most of the database information systems a quite fast operation. So that is one usual way to do that in that way. The second one to do that in that way from the point of view of the SQL Server is that SQL Server for a long time, SQL Server didn't have a date data type. They have a date time data type, like this stuff, but for a very long time, they didn't have a date data type without time. This date data time comes up maybe SQL Server 2012 or 2014. I'm not quite sure about the date, but quite late. And since we have that date data type, which is stored in 3 bytes, that saves us 25% of space for the date column. And it is the engine can process that date data type in the same fast manner with the same performance like that 4-byte integer. So since that time, from the perspective of SQL Server, we can switch to we can switch from using an integer value and kind of surrogate key or ID to use the date field itself. That may be differ if you have a look at other database systems like Oracle or Postgres or whatever. It depends from database system to database system what the better way is to connect the data, the dimension data to the fact data. That's the column, the attribute which a join is made. Okay. A second point we have to recognize regarding fact data is a mechanism called time intelligence. Time intelligence, that's the more or less official term for that. But it's not regarding time, it's all regarding date. So the better term may be date intelligence, but nobody calls it date intelligence for whatever reason. That kind of time or date intelligence are time-related calculations, calculations regarding the time is going on. Searching for the English word. Give me a second. It's along the timeline. That may be the best. The German word is Zeitstrahl. Yeah, timeline is the English word. Okay, that means a bunch of calculations along the timeline. Something like, give me a percentage to my previous period, or give me the same period of previous year, or give me a year to date. That means please cumulate all the values from the beginning of the year until now, all things like that. That is quite powerful stuff, because of if you define that kind of time intelligence in your time dimension, in your date dimension, then you have that kind of calculations. You have to define that only once in your date dimension, and you can use that kind of calculations for all measures, for all KPIs you have in your fact tables. And you don't have to create a year-to-date measure, an improved percent measure, an improved year measure, and so on and so on. And because of the formula is always the same, only you have only to switch to exchange the KPI. It's the same formula in next KPI, same formula next KPI. And if you have to implement that regarding measures, you have to do a lot of stuff which is quite redundant. There's no need for dealing with such stuff. And there's a quite good support for time intelligence, especially in the multidimensional models. That means in the analysis service cube model, as well as in the tabular model, which you may know from the Power BI suite. There are a quite good support for that time intelligence stuff to be able to define that kind of calculations only once and use it for every KPI you are interested in to use that stuff. Just give me a second for a cup of tea. So let's go on. Here we have some samples. We have the timeline over the different columns. And what we have here are a bunch of time intelligence. Please apologize, that is a screenshot with a German naming. We have here the current period, we have the previous year, we have the overall year, we have the overall previous year, we have a difference to previous year, we have a percentage regarding previous year, we have a previous period, different previous period, and so on and so on. And here we have that kind of year to date and regarding with differences and percentages and so on. And there are more than such kind of calculation depending on what your business needs are. I had to work on a project a bunch of years ago. They had a kind of they need a kind of rolling window. They also want to know, okay, what is my value in comparison to the value 5 months ago, things like that, for whatever the business need was. All such stuff is quite easy to define, quite easy to implement using that time intelligence, which is date intelligence and not time intelligence. Okay. So special point regarding dealing with times, there's only a short sidestep regarding that, is if you have to deal with state machines. That means if your fact table is a kind of log file and you have to deal with state changes over the time, maybe on Monday your customer has a state A, and on Thursday it changes to C, and on next Monday it changes back to whatever, things like that. And independent from that kind of changes, you want to know some things like, okay, how many customers in state whatever we have on Thursday. But it can happen that that we have no changes on Thursday. So we have to go back in time to find out what is the last recent state, to find out is it state A, B, or C, to count that stuff and deliver that for in respective measures. That slicing in any dedicated point in time is quite heavy stuff. Here's a quite sample, a little sample with we have 1, 2, 3, 5 states for that cryptic order ID. We have a state null 8, 8, 7, 10. Here we 8, 15, and so on. And you can imagine if we want to know how many orders are in state whatever and a dedicated point in time, then you have to slice here in and find out how the values are. That's not quite easy. There is an interesting blog and article regarding that from Lars Rönnbeck. Maybe you have heard of him. On www.anchormodeling.com, there is a sub area called Let's Twine Again. And he describes a quite cool architectural mechanism to deal with that special kind of dealing with timelines and data. Okay. A next point which can be important if we deal with fact data is do we deal with postings or do we deal with balances? Dealing with postings is quite easy. There's no problem with aggregations. Posting means we have on 1st of May we get 3 orders, and 2nd of May we get another 5 orders. That means in summary for May, on 2nd of May we have 8 orders, and so on. We can aggregate that 3 and that 5 and all the other values using all the hierarchies we have. The downside of dealing with postings over a very long time is there is no problem to aggregate, but if you have a long timeline, which big amount of data which is spread on that timeline, and you need a balance. You want to know how many contracts I have at the end of May for the whole year. Then you have to calculate that right now. And if you want to do it for the next month, you have to calculate it again. That means postings are quite easy to aggregate, but you have to aggregate whenever you want to get information about a balance. That's why a good idea is to combine that postings with, for example, with a starting balance per year. Maybe per calendar year or maybe per fiscal year, depending on your business calendar. To find out, okay, what is the start amount, the start balance of whatever account, whatever business object, and give that as a start value, and then postings over the year. And if the next year starts, you let it start again with an next year starting balance, as well as with all the postings which are coming in over the year. And that is good. That's a good possibility to combine that with the earlier mentioned year-to-date stuff, because year-to-date is your friend whenever you want to know the balance if your data are only if all your data are postings. That's the relation between both. Okay, that was an alien as well. Okay, that's regarding postings. The next one is from time to time it happens that your OLTP system delivers you balances at the end of a day, at the end of a month, at the end of a quarter, or something like that. To deal with balances is quite heavy. The first problem is balances are not aggregatable over the time, because the balance of May is not the balance of January plus February plus March plus April. But on the other hand, balances are also are aggregatable along other dimensions. If I have the balance of customer 1 and customer 2, I can calculate, I can aggregate quite simple an aggregated balance of customers region, customers department, or things like that. But not aggregatable over the time. That is the first problem we have. And the second problem we may have is if we have a big spacing between two balances. I had to work in a project at the beginning of this year. We got such kind of balance data, but we got such data once a year or 2 times a year, or the next data 5 years later. So we have big ranges, or a big distance. We have a big distance between 2 deliveries. But if you imagine we get data for 2016, and next new data we got for 2022, but we need all, that means the data from 2015 are also valid in 2016, 17, 18, 19, and so on. But we have to have that data in the other years, in years in which such data not really exists. That is a point we have to deal with. Okay. There are different ideas to deal with that problem. That is depending on what your tool set is able to give you as tools. There are such functions like last non-value or something like that, which can be helpful in that case for such kind of projection. Or you can use the year-to-date functionality. That means you have to duplicate the value at start value for every year, and if you create a measure regarding that value which uses the year-to-date feature, then that year-to-date feature virtually copies that value to all days in your year, because you have only one start value and no other value comes up during the year. So the year-to-date aggregation, which aggregates all values until now, aggregates the first value plus null, plus null, plus null, plus null, plus null, plus null, and you have the same value in that measure using year-to-date over the whole year. That is a kind of thing you can use, or not the best way, but sometimes it is an appropriate way to duplicate the data on relational side or on a side of your tabular or multidimensional model if you have one. That is the second problem regarding balances. And the hint is avoid balances as much as you can. One good way to do that is to convert balances to postings on the relational stage using new value minus old value is new balance minus old balance is a kind of virtual posting. And so you convert your balances in postings, and then you are back on the posting side and don't have to deal with all that strange balancing stuff. Questions to that regarding that? Okay. So we have to hurry up a little bit. Regarding data mention and calendar, a point you have to deal with is holidays. There are different kind of holidays. There's a question. Just a second. Okay, let's do that question. Postpone to the question and answer session afterwards. Okay. Holidays that are important for depending on the business you have to do. In some cases, not only the official holidays can be interesting to you, but also non-official tradition days or such kind of single days between a holiday and a weekend. In German, we call such days Brückentag, like Bridge Day. I don't know whether that term is also used in English. So not official holidays. Please keep that in mind, depending on the business you have to manage. So, and regarding the holidays, we have fixed holidays, which are on the same date on every year. That is something like May 1st, the Labor Day, Christmas, the New Year's Day, and things like that. Fixed holidays. But on the other hand, we also have floating holidays. Best sample for floating holidays are Easter and related holidays. Holidays related to Easter are, for example, the Good Friday, the Pentecost, the Ascension Day, and a bunch of other things. In Germany also, but also things like Carnival, Fastnacht, Rosenmontag. Maybe you heard of that strange kind of holiday. All such holidays depending on the Easter Sunday. Another floating holiday in Germany is the Sunday before Advent, on which the dead are commemorated. The German word is Totensonntag, and the related holidays are the 1st, 2nd, 3rd, and 4th of Advent. That are the Sundays before Christmas. The calculation for that stuff is you have to find a starting point and to use relative references, positive as well as negative references regarding that starting point if you want to calculate on which point in time, on which date in a dedicated year is such kind of floating holidays. Next point, holidays may vary from state to state. In German, we have that we have another amount of holidays in Bavaria instead of Niedersachsen. And holidays may change over the years. There are upcoming holidays which are not exist in the past. There are some holidays which are cut off and never exist from now, but they exist. They existed in the past years. Quite heavy stuff from the business perspective. Now let's have a look at the technical part, at the related SQL functions. What we have here, which looks quite funny, is the formula which is able to calculate on which day in a year is the Sunday of Easter, depending on the year. That means the year is the parameter which goes in that function, and then we have to that very strange looking kind of calculation, and then we get a date, time, and date, which tells us, okay, on that dedicated date in that year you requested, we have the Sunday of Easter. That's the same mechanism regarding that day of commemoration, which is the Sunday before 1st of Advent. It's not such, that's not so complicated like that Easter stuff, but it's also a little bit strange to deal with. So that is all what we can find regarding our calendar. When we create a date dimension, which is a table which only usually is created once. If you establish a new data warehouse, you create a data dimension from maybe 50 years in the past until 50 years in the future. That's you have to do that only once and you are fine. But depending on how heavy you have to deal with such kind of holidays and moving holidays and fixed holidays and so on, it's a good idea to have that holiday information in your data dimension as well. And for that reason, such functions can be used to calculate the starting points for that kind of moving holidays for create a date dimension. Another question which comes up more and more in different projects is how many business days we have between date 1 and date 2. Oops, it's a little bit confusing. I have to check that here because we have to talk about date 1 and date 2 to prevent from confusing you. Save and back to presentation. So if we have to eliminate weekend days, Sundays or Saturdays, that may be done by a more or less complex formula, something with modulo by 7 and things like that. But if there come holidays in the game, especially regarding especially regional holidays, then we have to deal with quite heavy mechanisms. And the point is we want to have a mechanism which is which has the same performance independent how long our range is. It is quite easy to have a kind of iteration which goes to all the records in our date table to find out is it a holiday or not, and calculate +1 or not +1. That's quite easy to do. But if you have to answer the question how many business days we have in the last 5 years, then it takes a lot of time to go to that 5 times 365 records. The question was, how can we find a mechanism which is as fast as possible, independent how long the time range is? I want to get that information, how many business days we have. What we need first, what do we need first? We need holiday master data. That means we need information about which holidays do we have. And we need a kind of mapping table, which holiday is in which state, which holiday is relevant for which state, and what are the valid years if we have holidays which are gone away or which are upcoming. So let's have a look on that master data. It's quite easy. That is the table of such kind of holidays. I apologize again for the German wording here. And we have some technical informations which are related to the mechanism to project that holidays on a calendar table for a bunch of years. There are some special information here. For example, we have seen that function which calculates the Ostersonntag, that is the Sunday of Easter. And then we have a bunch of holiday days which are related to that. For example, that Friday is 2 days before Easter Sunday. Easter Monday is 1 day later. And there are other holidays which are 39 days later, 49 days later, 50 days later, and so on. And that informations are here in a kind of repository style stored in that table. I don't want to go too deep in that. I only want to talk about the principle. And we have a holiday ID here, and that holiday ID we can find here, and we can see the mapping for which state, for which German states in that case, is that holiday exists, that holiday, and from to which point in time it exists. That is, that means from the beginning of the time until the infinity. And here we have some kind of holiday that is a Reformationstag, which only exists for 1 year in some states. In other states, it exists up from 2017 until the end of the days. And so we have different circumstances. And both tables together give us the ability to create a date table and to mark in every dedicated year the related dates with the holiday flag. That's what we want to do. So we use that kind of metadata to process a calendar table only once a time. Mark every holiday, every business day, holidays on weekend, and things like that. We have to deal with the special case that there is more than one holiday on a dedicated date. In German, for example, it is possible that the holiday Christi Himmelfahrt, which is a moving holiday related to Easter, can be on the same day in the calendar as the 1st of May, which is also a holiday in Germany. So it can happen that we have 2 holidays on the same date. That happens in 2008, I think. Okay, that makes things a little bit more complicated, but it's we can deal with that. And if we have the business needs, then it's also maybe a good idea to mark the weeks with a related caption. Okay, that's the Easter week, that's the New Year's week, or something like that. In case of that is interesting for your business. So that is a short part of such kind of date table for 2000. We have here some of the holidays with the respective marks, with the week caption, and things like that. Only to give an idea how that kind of date table is prepared. For the date arithmetics, I want to mention to you, we have to calculate some support data to make it easy to calculate that kind of business day differences. Such kind of support data are things like that. We have the number of days. It's only +1, +1, +1, +1, +1. But we also have the number of Sundays. Okay, until the 22nd of April 2000, we have 16 Sundays. And 23rd of April of 2000 is a Sunday, so we raise the number of Sundays by 1, and on the next Sunday by 1, and so on and so on. So we know how many number of Sundays we have. And the same with the Saturdays, with the holidays, with some other days. That is a kind of pre-calculated values we need for a quite fast mechanism. So, and how we can deal with that? It's quite easy. If we want to calculate the amount of business days between 2 dates, I have to do 2 seeks in that table to find the record I want to start and the record I want to end. And let's assume we want to calculate from 24th of April to 5th of May. Then we have to use that value. We catch that value, which is 18. We catch that value, which is 17. and we calculate the difference, and we know, okay, in that time range, we have one Sunday. And that kind of difference calculation we have to do with some other special prepared numbers, not only the number of Sundays, maybe also the number of Saturdays, maybe the number of existing holidays in that time range. But at the end, we only have to go to the two records. We have to catch some of the numbers, calculate the differences, and at the end, we need a smart calculation of the differences. For example, the number of overall days minus the number of weekend days minus the number of holidays in a dedicated time range is the number of my business days. And independent from how long my range is, I have to seek two records. I have to grab some of that pre-calculated values, and I have to do some smart difference calculations, and that's it. That mechanism is independent from how long the range is. We need additional support data regarding the inclusive border approach. That means if we want to calculate from Monday to Friday, which are 5 days, it's not a good idea to say, okay, Friday minus Monday, because Friday minus Monday gives you 4 days as a result. But when we talk about a time range, we usually want to include the first and the last day as well. So we do have on some points in the algorithm, we have to do some additional +1 to fulfill that inclusive border approach. So close to the end. As we established that kind of mechanism, the idea was, okay, to encapsulate that algorithm within a scalar function. That is a great architecture, but we got a lousy performance. As you know, scalar value functions have to be called for every record separately. You have all that parameter giving to the function calculations the way back. The calculation itself is not the problem, but there's a big overhead to call that function, to return the values and things like that. So my experience was keep off from that. From architectural point of view, good idea. If you have to, if you have a big amount of data to deal with in that. The better approach is create a good documentation on how the calculation have to be made, what values you have to pick, what plus and minus you have to calculate, and then your developers will be able to implement the respective formulas in their set-based statements with a very, very huge performance effort regarding dealing with that quite cool scalar functions. Bei Fragen, Fragen. That's a German wordplay. In case of questions, please ask right now.